Assalamualaikum and hi. This video lecture is about one type of relation which is transitive. The definition of transitive is given like this. R is transitive if you have two ordered pairs that you need to find. If AB and BC is in R, if AB is in R and BC is in R, then AC should also be in this R, then it's transitive. This is the definition given. This time you have two ordered pairs that you need to find. I always say to my student, let's start with this. 1, 2 and 2, 3. Okay. You imagine this A is 1, B is 2, C is 3. B should be the same. A and C can be the same value with B, and also it can be different. It doesn't matter. What matters is that B is the same. You need to find these kinds of pair first, 1, 2 and 2, 3. It is transitive if it has 1, 3. That's why you can imagine this like this arrow. A, there is a route to B, and B, there is a route to C, and it also shows that A can be connected to C. Okay, this time I don't want to start with R1, I want to start with R2 first. R2 ordered pairs, A less than B, 1, 2, 1, 3. One, 4, 2, 3. Okay. Just now I already showed that 1, 2 you can find 2, 3 and so on and so forth. Then it must have 1, 3. And that happens to exist in this particular example. 1, 2, you try to find B. You cannot take 1, 2 and 1, 3 because it will be different B's. You try to find 2, which becomes at the front on the left. 2. So there is 2, 3. When you have these two conditions, then you can check that there exists 1, 3. 1, 3 is inside. These are 2 here. Okay, proceed to the next one. 1, 2, you can compare it with 2, 4. Does 1, 4 exist? Yes, 1, 4 exists in this R2. Is there more? Where 2 becomes the element on the left? No. Then you can proceed to the next one, 1, 3. 1, 3 you can compare with 3, 4. And 1, 3, 3, 4. 1, 4 exists in R2. Finish. 1, 4. There is no 4 as the elements on the left, so you can skip. 2, 3. There is 3, 4. You should have 2, 4. And yes, 2, 4 exists inside R2. 2, 4 no. 3, 4 no. So that concludes our search for the proof As our conclusion, R2 is transitive. And what is your justification? All of this is your argument. We proceed with R6. Let's try R6. R6, huh? A, B, A equals to B to the power of K. Okay, then what is the element inside? 1, 1, 2, 2. Or 2. I double check first. I think that should be all. Now the question is R6 transitive? Okay, this time we have different kinds of explanation for 1, 1. Remember just now I just said that it's easier for you to find when B must be the same. A and C can be the same and also can be different. The thing that might be confusing for the students is for the case when A is equal to B, like this one. 1, 1. If we set A equals to 1 and B equals to 1, so it's still valid. 1, 1. You try to find B equals to 1, it will be 1, 1. And if we treat this, this is A, B, and this is B, and this is C. So what will be AC? It will be 1, 1. Of course, if A equals to B and B equals to C, then AC will also be the same. A equals to C as well. For this particular argument, I made it not compulsory for the students to write it because this is quite logical and it is quite repetitive. Let's proceed with 2, 2. The argument also the same. 3, 3 also for 4. Let's look at 4, 2. Okay, 4, 2 is a little bit different because we have 2 different values there. But for 2, try to find where B equals to 2. There is only one, which is 2, 2. What will be the AC? It will be 4, 2 back. This is the case when A is not equal to B, but B equals to C. Then it will reflect back that it will be AB back. AB, this is BC. As you realize, this is our AC and this AC is equals to AB. Again, for this particular example, sometimes I don't make it compulsory for the students to write all of this. So that's why sometimes we try to find the question which have different particular A, B and C values. Or better yet, we try to avoid this question and we take a little bit harder question. In the next lecture, that concludes the example for transitive, or we want to try one more? We try one more. The last one, R8. AB, A divides B. Oh, by the way, this is a symbol for divide as well. A divides B. This is like 3. Curly bracket. Okay. if A equals to 1, 2, 3, 4, for the case of finite set, then you have 1, 1, 1 is a factor of 2, 1 is a factor of 3, 1 is a factor of 4. You have 2 as a factor of 4, 2, 2, 3, 3, 4. Is this transitive? We already discussed for the case for 1, 1. Try to find a different 1, 2. Yes, we managed to find 1, 2. We pair it with 2, 4 because these are different A, B, and C. Check. Is there 1, 4? Here is 1, 4. 1, 2, 2, 4. 1, 4 is inside this R8. Other than that, I don't think I find another different sets of A, B, and C. The best that I could find for 1, 2 is 1, 2. I managed to find 2, 2. And of course, it will be 1, 2 back. This is the case where I say it's not compulsory for the students to write. I'm more interested to find the students' answer for this statement. Otherwise, for the other, you will find it will be like the previous argument that I said just now. It will be quite repetitive. Based on this one statement alone, if the student managed to find this AC for AB and BC, R8 is concluded to be transitive. It's enough for me, it's sufficient. Because I can write this black, or you can just leave it the argument at the top. R8 is transitive because for 1, 2 and 2, 4, 1, 4 as is in R8. That is sufficient for this question. As you realize, we only discuss the types of relation that happens in the case of finite set 1, 2, 3, 4. In another video, a bonus lecture, I want to focus solely on the case of infinite set. If you look at the slide on the left, determine whether this relation is transitive on set A, 1, 2, 3, 4 and Z. Z integer, a set of infinite integers. For this particular infinite set, you happens to take like Cartesian product Z times infinite. This is a case of different color, please. Infinite sets. We want to determine the types of relation as happens to infinite set as well, because this one is much more interesting and much more challenging. In order to prepare for this type of infinite set, you must have a good grasp of logic, good understanding in proving. Then we can go back to understand the concept of relation in infinite set, hopefully in another video. This concludes the lecture. I hope to see you in another video lecture for different topics. Thank you and bye-bye.